but Roman is. Okay, today we move along to a different topic. We sit in the midst of implicit differentiation. So far, we have done explicit differentiation. Here's some examples of explicit equations. F of x is equal to x squared plus 3x minus 1. Ooh, exciting. Y equals the square root of x squared plus 1. Super exciting. S equals t over t squared minus 4. Oh, Mr. Gentz, you're blowing my mind. The reason why I call it explicit is it's solved explicitly for one variable. Here it's solved for f. Here it's solved for y. Here it's solved for s. Examples of implicit equations, different. X squared plus y squared is equal to 3. How do you take the derivative of that? Goodness gracious. Or how about this one? XY is equal to 4. Oh boy. Or how about this? X times the tangent of y is equal to y times the sine of x. All of a sudden, your brain's starting to ache, isn't it? Mr. Gantz, please help us through the confusion. You don't get to raise your hand. You haven't been here for a week. Yeah. This is explicit because it's a variable equals, variable equals, variable equals. It's solved for the variable. Whereas here, it's not solved for the variable. What is x or what is y? What is x, what is y, what is x, what is y? Not stated. Question. Very good. So if you had y is equal to 4 over x, then we turn it from an implicit into an explicit equation. Now, very easy to do with x times y equals 4, right? A little tougher to do here, isn't it? Yeah, a little. Katie's not afraid. She's ready to step up. Okay. So, terminology, we have to look at what we mean by derivatives. This means the derivative of f with respect to x. So it means the rate of change of the function with respect to x. It deems x as the variable and f is a function. The rate of change of f. This also means derivative. What does this mean? This means simply the derivative with respect to x. It doesn't state the derivative of y or the derivative of z or the derivative of f, simply the derivative with respect to x. This states the derivative of y with respect to x. Okay. You have to be willing to stop me and ask a question as we go through this next piece. You got it? You good? Okay. If I take the derivative, how do I write the derivative? Now, the fact is that you have often just focused on what's happening on this side, but you have not focused on what's happening on that side. Okay? You haven't. So I'm going to show you a little bit different example. Okay? Suppose I rewrote this as negative 4x plus 2y was equal to 2. Okay? That is the same equation as this. Okay? I'm going to take the derivative. Watch. What's the derivative of negative 4x? You would say negative 4. What do you think is the derivative of 2y? See, that's interesting because you're right, it's 2. But notice how we always end up with a y prime over here, don't we? Well, if you said that the derivative of 2y was 2, what would be the derivative of y then? It would just be 1. But you multiply it by y prime. So watch what happens. The derivative of 2y is 2, and we multiply it by y prime. What's the derivative of 2? 0. Now watch what happens when I solve for y prime. I add 4 to both sides. And I get 2y prime is equal to 4. Divide by 2, and you get y prime is equal to 2, which is exactly what I have over here, isn't it? The fact is when you take the derivative of y, you get 1, but you multiply it by y prime. Okay, you attach a y prime. Now, your question right now is, why do I do that? I'm going to show you right now exactly why you do that, okay? If you can get through this obstacle, you're going to be just fine. So, find the derivative of the circle x squared plus y squared equals 36. So, I'm going to take the derivative with respect to x of x squared plus y squared is equal to 36. Differentiation tells me I could take the derivative of each term. So I take the derivative with respect to x of x squared plus the derivative with respect to x of y squared equals the derivative with respect to x of 36. Now, here's where kind of the magic happens. What's the derivative of x squared? 2x. Notice what happened to your x squared. It reduced by a power of 1, right? And what you could think of is you could think of that variable as being absorbed in the top. So you think of it like this, dx over dx times that 2x. You said the derivative of x squared was 2x, and we absorbed that x up into there. What's dx over dx? Look at this part, okay? What's the derivative of y squared? 2y, okay? Notice what happened to the y squared. The power reduced by 1. You could absorb that y up into here. So you get dy over dx 2y equals, what's the derivative of 36? 0. So that all just goes away, right? You multiply by 0. So look at what you're left with. Dx over dx is just 1. So you have 2x plus dy over dx. That means the derivative of y with respect to x, which is just a fancy way of saying y prime times 2y is equal to 0. Which variable up here do you think I'm trying to solve for? Y prime. How would we solve for y prime? Subtract the 2x, good. Y prime times 2y is equal to negative 2x. Yep, so y prime is equal to negative 2x divided by 2y. where y prime is equal to negative x over y. Now, there's two things I want to show you, and you're going to get very good at this, okay? So I know it's new learning right now. You're a little bit confused, but you're going to be taken out of that pretty quickly. First of all, we came up with the derivative is y prime is equal to negative x over y. Just watch this real quick. Our original function was x squared plus y squared is equal to 36. Can somebody tell me what shape that makes? It makes the shape of a circle, okay, with a radius of, okay? So as I mark this out here, this is what's really cool is this a function? Why is it not a function? Yeah, it doesn't pass the vertical line test, does it? Okay, but this will tell us the slope at any point on here given x and y. So this coordinate right here is 0, 6, right? Well, what's the slope right there? Yeah, the slope is 0. Watch what happens if you plug in 0, 6. You get y prime is equal to 0 divided by 6, which is 0. What's the slope right here? Undefined, and that's at the coordinate 6, 0. So if you were to plug in 6, 0, you would get y prime is equal to negative 6 divided by 0, which is undefined. Is the slope right here, we'll go, we'll choose a different color. Is the slope right here positive or negative? Negative. Now, that would be a positive x and a positive y for a coordinate, correct? Well, if you plug in a positive x and a positive y, notice that this turns negative right here, right? So it produces a negative slope. So this will, in fact, tell you the slope of any tangent line to a circle at any given point, okay? And all of a sudden now, instead of just working with functions that pass a vertical line test, you can actually work with any type of graph that you want using implicit differentiation. Kind of cool. So we go back to the previous piece earlier, which was we looked at negative 4x plus 2y was equal to 2. When we took the derivative of that, again, what was the derivative of negative 4x? Negative 4. What was the derivative of 2y? 2. And every time you see a y, you attach then a y prime. It's equal to 0. And so as long as you attach a y prime every time you take the derivative of something with a y, you're doing exactly what you need to do. Okay? So flip your notes over, and let's do some examples, and this will start clicking for you really well. Yeah. So we actually used both, didn't we? We and you won't ever have to think about that, okay? You won't ever have to decide whether or not you're going to use d over dx or dy over dx, okay? They both kind of mean the same thing. You're taking the derivative. It's just in terms of how we interpret it, okay? This produces a y prime. This does not produce a y prime, okay? As I did the derivative with respect to x, derivative with respect to x, derivative with respect to x, I just chose that because I was going to end up producing a y prime. You could actually do derivative with respect to y and produce an x prime if you so chose. It's really not necessary. Yeah. So if we take the derivative of y with respect to x in this situation, then there is no y variable here, is there? And so all of a sudden you end up with a y along with an x. So again, this just tells us what we're going to come up with through the result. Okay. All right, let's try this. Hey, buddy, how you doing? Great to have you here. So implicit differentiation. Let's rock it. 3x squared. What's the derivative? 6x. Derivative of 4y. Y prime. Derivative of 4x. 4. Solve for y prime. Negative 4y prime equals 4 minus 6x. Divide by negative 4. Y prime is, you write that as a positive 3 halves x minus 1. Now, if you notice from the very beginning, could we have solved for y from the very beginning? Yeah, you could, and then take the derivative. So I mean, there's two ways to do it in this situation. This would be harder to solve for y, wouldn't it? Definitely be more challenging. A lot easier to just use implicit differentiation. What's the derivative of y to the third? Y prime. Minus plus 2y prime equals, uh-oh, I've got two y primes, not just one. I showed you how to do this last year. We'll see who remembers. What do I do? Combine like terms, great idea. So we'll add the 5 over. We got 3y squared, y prime plus 2y prime is equal to 8. Still got 2y primes. Factor out the y prime. Y prime times 3y squared plus 2 is equal to 8. So y prime is 8 over 3y squared plus 2. Not too bad, huh? Try letter C on your own. Try letter C on your own. Gather your y primes on one side. Everything that doesn't have a y prime goes on the other side. Divide off your factor. We get 9x squared minus 1 over 4y minus 16y cubed. Are those the same? No, they're not. I'm kidding. Yeah, they're the same. You got it, bud? How would you simplify it? That would be factored, not necessarily more simplified. If you would factor something out and it would then cancel, we would say that would be simplifying. Factoring for the sake of factoring, not necessarily simplified. That would be a no. Okay. Letter D. What's different about this one? It's got an X and a Y together. Oh my goodness. Like if you were to actually read that mathematically, what does it say? 3xy or 3 times x times y? What do you think? Product rule, yay! So we'll call it's really no big deal. We're going to call the 3xf and we'll call the y g, okay? So what's f prime? 3 times y plus 3x times, what's the derivative of y? 1 y prime. So our rule for the product rule is f prime g plus g prime f, right? So we have the derivative of 3x is 3 times y plus g prime, the derivative of y is y prime, times f left alone, which is 3x. Oh, because I switched the f and the g prime. I often do that, yeah. It's a free country, so I'm going to do what I want. Plus, derivative 9x, 9 plus, whoop, sorry, no plus sign, equals 10y y prime. What do I do? What do I even do? Put all the y primes on one side. 3xy prime minus 10y y prime equals negative 9 minus 3y. Now what? Isn't factoring awesome? I mean, it's so useful. Gigi even wants to factor when she doesn't have to. It's like, hey, this is just going to make me feel better, so I'm going to factor. And we get y prime is equal to negative 9 minus 3y over 3x minus 10y. That's your derivative. Isn't it beautiful? Over 10y minus 3x. Sometimes people make grandiose statements that are a little bit overreaching. Write an equation for line tangent to the volume curve of the given point. Remember, this was day one, right? This is day one. We keep coming back to it. So in order to write equation for line, I need what two things? Point on a line and slope. I know my point on my line. It's negative 7, negative 24. That was super easy. How do I find my slope? Derivative. How do we even do that derivative? Impossible. 2x. 2y prime equals 0. Many people write 625 at the end. Don't do that. 2y prime is equal to negative 2x. Divide by the 2y. Y prime is equal to negative x over y. Turns out that for any circle, the derivative is negative x over y, because the derivative of the radius is always 0. Isn't that awesome? Okay, so how do I find the slope? What do I plug in for x? And it becomes 7 over 24. Are we good now? Okay, this is the derivative. We plug the point in for negative xy. The negative 7 goes in for the x. The negative 24 goes in for the y. We get 7 over negative 24. We good now? All right, y minus y1, so plus 24, is equal to 7 over negative 24 times x plus 7. So y plus 24 is equal to negative 7 over 24x. So it's going to take the x value and turn it opposite. So instead of negative 7 turns to positive 7. And the negative 24, it says it stays negative. Yep. If we want to make everything negative, then we would, no, that wouldn't even do it. You'd have to do like the negative at the top and the bottom, and that would just be the same then. So. Oh no! I need a common denominator. 24, so that'll be 576 over 24. So I'm going to, well, 24 squared, you know that. So I subtract it, and negative 49 and negative 576 make, yeah, negative 7 over 24x minus 625 over 24. No. You try letter B on your own. Go. Nope. Not for the circles. Ooh, a vertical line has a slope that's undefined. So if it's a vertical line, it would be an equation of x equals, right? What is the x value that it passes through? Okay, I will redo the problem again for people. In the meantime, I will hand out the new worksheet.